Hello. Hello, am I audible to you?
Yeah, just give me just one moment.
Yeah, sure.
Okay. Uh, okay, yes. So I'm gonna turn my camera as well. How you doing, Kanika?
I am good. How are you?
Good, good. Yes, getting ready.
Yeah, actually, I just want some basic information about you, like what
Oh,
ground you are from and how much you know about AWS Cloud, right? AWS services you already know because it will be a good prerequisite if you already know much of the content, right?
okay.
So just
Um,
give me a brief like about your past experience with AWS.
okay. So I'm been like taking courses, like online courses, like Udemy. Um, like since September through like all the way. So I've been studying and been like practicing in the console. And I recognize that in order to advance and pass the test, I have to like sharp my skills in certain areas that I am like very weak and I don't understand so much. And then I decide to look for tutors to help me in those areas that I miss. And just getting a job and then have fun.
Okay, so like what all topics you already know that you have completed regarding AWS?
So I am just in the I am services. EC2, I have been practicing a lot in EC2. I know how to connect the instances, private instance, getting the internet gateway in the VPC, the route tables, the um, well, EC2, load balancers, target groups, auto scaling. Have been practicing like I think I'm very good at it. And in the PPC console, been practicing on the route tables, on the subnets, how to get the IPs. Um, I know the website that I can calculate the IP subnet. Um, and yeah, so I was practicing the VPN, the VPC peering, the VPC sharing. Yeah, I think I need like more practice on that, but I know how to do it. So just need how to just to repeat the same thing all over again. But I'm good on the route table.
So, Okay, you know like basics of AWS, right? Like what is EC,
Yeah,
what is
the
S3 bucket. These concepts are very much clear to you, right?
yes, yes.
Yeah, because the topics you have mentioned, let me specify them. You're able to see my whiteboard?
Uh-huh.
Okay. So first topic you have specified is SNS. Okay.
Yes.
Uh, and another one was SQS.
SQS.
So these are both the messaging services.
Messenger. Uh-huh.
Okay, these are the message services. So you need at least need EC2 instance knowledge and S3 bucket knowledge. Okay, these are the basic prerequisite you need when you are dealing with these two concepts of messaging. Okay.
Okay, perfect.
Yeah, and the third topic you have specified was database. So for connecting
Database.
databases, you again need these services. Plus, in addition, there are five more services that you need to understand. So when we will deal with the database, I'll again ask you if you are very much familiar with these five more services of AWS. Okay, so that we can just go and revise it once if you are not. Okay,
Got it.
another topic that you have specified was serverless. So see, these are the topics comes in advanced section of AWS learning.
Mm-hmm.
So they require a little bit complete knowledge of the basic tools, basic services that AWS provides. Getting it? So
Got it.
from my side, let's start with SQS first. Okay, so that you can understand the basics, what SQS is, why we are using it, and then the implementation part. So how we are going to follow the pattern. Okay. So today
Okay.
in SQS AWS service.
I have a question. Can I record it?
Yeah, actually I'm recording it for you. So I'll send you a drive link where I upload this video so that you can
Okay, perfect.
go and revise it again.
Thank you.
Yeah. Okay. So see, I have just planned some things for you. When you're starting with AWS service SQS, what things you need to keep in mind? First thing, how how SQS works. This is the main important concept you need to understand. The second concept, what are the cases which come under SQS? So first we will complete this part and then we will move to another depth theoretical parts for SQS. Okay. So see, I think you need to clear an exam, right? You are preparing for an exam.
Yes.
So see, in exam from my side, there is a theoretical part, okay, the
Uh-huh.
implementation part. So in your exam, which part is having the more weightage? The theoretical part or
Um, I think because they use both, but like most likely they are more on the theoretical part on the test.
okay, so see, actually I'm covering complete theoretical part also and the implementation part also. But
Great.
in implementation part, there are multiple different cases, multiple different problems that you can solve using the single service. Okay, any AWS service you take and you can solve multiple problems using a single service. So there can be multiple problem statements in the implementation part. But in theoretical part, concepts remains the same. It will not change regarding any of the cases. Okay, so if we are very much strong with the theoretical concept, then we are able to implement any of the implementation part. So I will take the implementation part, the basic one, how to create it, and how we can build a model according to it. Okay. If else you require to solve any other case, just let me know. We can just follow that also.
Mm,
Okay.
great.
Yeah. So let's start with the first topic that I'm taking is SQS.
SQS.
Okay, so it is an AWS service, very much clear with this AWS service. So see, in what this queue identifies, queue says it is a queue, and a queue in general English means a line. Okay, so first
Mm,
we have to just try to understand in this way. We have to send some messages, okay, to a particular server. Okay, you have to send a message to your friend, say S. Okay,
okay.
say message 1. Okay, and there's another message 2 you want to send to your another friend, say S1. Okay, so how should these messages be arranged so that they can be sent effectively to a respectable person? To solve this issue of arrangement, we will make a queue, right? What
Mm,
a queue does, it arranges the messages in a sequential form. So say first message, second message, third message, fourth message.
mm,
Right? So what this service is doing, it is arranging the messages so that sending of the messages becomes sequential,
sequential.
as well as no duplicacy will be there. Okay, if see, try to understand with have you ever used Amazon services like Amazon shopping website?
Yeah.
Amazon so shopping website.
Uh-huh.
See what happens. First of all, first window comes in which says you have to apply with your login ID, right? First
Yes.
into the Amazon shopping site, right? So this is the first task we are doing. So this task is handled by server, say server 1. Okay, then there is another thing you have to do. Once you have login, you will go and search for a product, right? You are searching for a product. Say you want some eatable items. Okay, you need some food, so you are searching for this product. This is the second step you want to do. Okay, but
Okay.
and this is handled by another server, say server 2. So how does any application or any web application will know that you have logged in and what next step you want to perform? So this connectivity we have to arrange in a queue. Okay,
In a queue. Mm-hmm.
yeah. So that what the Amazon server people will do, they will say there's a user, okay, who has just logged in into the Amazon web servers. Okay, Amazon shopping service, they have logged in, they want, and they have provided their login ID. So that task has been completed using what? Server 1. Server 1 has already implemented this task. Now this will pass the message to server 2 that my task is complete. Now it's your turn to complete the task. So they will show us the list, the web page of this website. Okay, they will show
Mm.
the web page where you can go and select the items. This is done by server 2. Now this task is complete. We have seen how many products, all the products that we want to buy, and we have selected one product. Okay. Now another thing comes up that once you have selected a product, you want to buy it. So what you will do, you will add it to a cart. Amazon
Uh,
service cart you will add, right? So this is handled by another server. There are multiple servers working behind a complete system. So this S2 will say, my task is complete. Now you can just move on to S3 server, and S3 server will handle the cart part. You will go there and do it add to cart that I have selected this item for buying. Okay. Once this task is done, the last step, what it is? The billing one.
uh-huh.
So billing will be done. Similarly, this chain goes on. So how this arrangement is being made, how this message is going that First task is complete, second task is complete, third task is complete, fourth task is complete. So what they are doing? They are doing server 1 is sending message to server 2. Server 2 is sending message to server 3. Server 3 is sending message to server 4. This is what? Sending messages, right?
Sending messages.
Okay, so this is what one application, application say server is sending a message to another application, okay,
Not order.
to make it more sequential. Okay, to make it more sequential, we have to arrange them in a queue so that they can be easy to implement and there is no problem of any mismanagement. So we will send the messages. The main task is to send the message, right? But in a way so that it is arranged in a form of queue. Getting it?
Got it. Oh, it's clear.
Yeah. So see, one thing you can say, if you take this server, let's take another example. This is server 1. Okay. This is your S3 bucket. This is your server 2. And here is another S3 bucket. I'm taking only single message now. Okay. Working with single message. Like you have to just send a single message. Right. So first of all, to send any message in SQS means queues, where the queue word comes, what you have to do, you have to create a queue like this for sending message. So for sending message 1, second message, third message, fourth message, fifth message. This is for this server 1. So you can say this is, and for another server, you have to make another queue. Okay, say fifth, like a fourth message, third message, second message, first message. Okay, and this is queue2 for the server 2, right? So this is the basic architecture. What Amazon's AWS service SQS follows behind the scene. You will never able to understand it by just looking at the implementation of the service. This is the backend part called architecture of SQS, how SQS internally works. So try to understand. Okay. So say you have to upload, one example I'm taking. Okay. You have to upload a YouTube video. Okay. You want to upload a YouTube video. So first of all, say this is server 1. This is the user who is willing to upload a video on YouTube. Okay. So what this user is doing, they say they have the video in AVL format, .aval format, they are having the video. So they want to upload this video on the YouTube channel so that multiple people can view and share it. Okay. So first thing, what message will go in SNS, SQS, that first message is that I am trying to upload a video. So this will be the first message they will get.
Okay.
Message from the user to the server. So it will be counted as first message. Okay. The user is giving to the server that I am trying to upload a video of .aval format. Okay. Now what S3 bucket is doing? S3 bucket is continuously watching this queue. So whenever a new message comes up, okay, like this first message is coming, S3 bucket is continuously watching this Q1 so that as soon as a new message comes up, they will detect it and start the processing. So what it will do, they know that in server 1, there is a video has been trying to, some user is trying to upload a video of .aval. So what server 1 will do? It will provide this video to S3 bucket, right? How S3 bucket will know that this someone is trying to upload the video? Because it is constantly looking the Q1 part. It is looking for the queue. If any message comes in the queue, it will automatically, S3 will automatically detect this message and try to convert this video from AVL format to MP4 format. This is a general process happens whenever a person is trying to upload a video. Okay, once this video is uploaded, okay, in the S3, once this video is uploaded, what next step we
Okay.
do? We have to we will send this video to second server. What is the role of this first server? This server is just used so that a user can push the request of a video that I am trying to,
Video.
yeah, I am trying to upload a video on YouTube with AVL format. Okay. And this video is now inside the S3 bucket, right? Now, what is
Yes.
the task of server 2? Server 2 wants to convert this AVL to MP4. This is the task given to S2 server. In S3, the video is already there, but it is in AVL format. Now, what we want to do, we have to convert it to MP4. For that, server 2 will help. So, what will happen? This S3 will send this video to this server 2. Okay, and as soon as server 2 receives a message that there is a S3 service which is trying to send me a message or a video, it will inform the Q2 that there is a message for inside server 2. So here this S3 bucket will, which is continuously monitoring this queue, what it will say, okay, I got a new message. So after conversion, first server 2 will convert the AVL video to MP4 and then it will store it to S3 bucket again. Now what is inside the S3 bucket? It is the .mp4 video, right? And after we get it, it will directly upload it on YouTube. This is a general format any of this S3 service will use. Okay. One thing very much important in this, that how this process is going on. So to simplify it, see, first of all, there is a user here. Okay, this is a user, right? It is sending video to server 1, right? What this server 1 is doing, this server 1 is sending a message inside Q1 that I got a message. Okay. Then there is a S3 bucket here, which is used for storage. Yes, storage. S3 bucket is used for storage. So when server 1 will inform that I am having a video with me, okay, with .avl format. So what this S3 is continuously monitoring this queue. Okay, it is continuously checking if any message comes in, I have to respond. So S3 will detect there is a message. So what will happen? From S3, from server 1, this video has been stored in S3 bucket. Right? Now S3 bucket has .avl video. Now what is the next step if you want to upload a video on YouTube? That you have to convert it into MP3 format, MP4 format. Okay. So what server 2 is doing, it is converting it to MP format. So what will happen next? From S3 storage, this video will go to S2 server. Now S2 server already has its queue because we are using SQS service of Amazon. So every server will have a particular queue in which message will be arranged. So as soon as this S3 bucket will send a message to server 2 that I am sending you a video, you have to convert it from AVL to MP4. Okay. So it will show up in this queue that I am having a message with you. Now what you have to do? You have an S3 bucket. So First, you will convert this using this server. You will convert this AVL video to MP4. Okay, and then you will send it to S3 bucket. Now in S3 bucket, what do we have? We have a converted MP4 video which we will upload. Getting it?
Yes.
Just go through it if you have any issues.
It's like the sequential. And what is the job of the SQS is to the queue to manage those messages in a sequential and orderly and logically.
Yes, see, I'm talking about only one message right now. Only one single message I'm talking. Right? This single message that upload, one single video is there, which needs to be uploaded on YouTube. But but it is not the real case scenario. In real time world, there are hundreds of videos that is trying to upload on YouTube, right?
Okay.
So what happens? There are multiple users here. Now try to understand with multiple user example. See, this is user 1, this is user 2, and user 3. Three users are trying to upload video on YouTube. Right? So what will happen? This is the server which is trying to take the .avl file from the user. So what will happen? At a single time, 3 users are accessing this server. Right? So 3 messages need to be generated according to it. First message for first server, second message for second user, and third message for third user. Like this in the real world happens. Okay? 3 people are trying to upload a video on YouTube. So 3 messages will be sent by will get in the queue. Okay, say Q1 because it is server 1. Okay? Now we have the S3 bucket here, which is observing this queue for the messages. So what it will do, it will detect the first message and then store it in the S3 bucket, right? Then it will go send this first message to the another server, say server 2, which is converting the .avl format to MP4, right? Then this first message will be in the queue of the second server, right? And this second message will be detected by another S3 bucket, and this first task is complete, right? Then it comes to the second task. Similarly, what S3 will detect, S3 will detect now there is a second task also. Similarly, it will take it into S3 bucket for the second one. So as we have the second user video, then it will send this second user video to S2 server for conversion. Now here the second message will be denoted that now the S2 server is getting the second message for the second user video, and then it will go to the S3 bucket. Finally, 2 users videos have been uploaded. Once 2 users are complete, then the similar step will be followed with the third user. But this process is so fast that it is not visible to us, right? We are not able to detect this process while the uploadation of the videos. Okay, but it is actually the way the users use the SQS service for sending messages. These are all messages, right? One server is sending message to another server is sending message to S3 bucket. So it is application to application messaging. One application is sending message to another application, but using queue. Getting it? And another thing is, an application can send the message to a person also. That is also known as a message only, and that can also be done using a queue. Getting it?
What is that like that you mentioned? Can you repeat that a second?
Sorry.
The second step, the number 2A.
See,
The,
application, say, any
uh-huh.
application that is, you can say Amazon, Amazon people, you have shopped something from Amazon, right? You have shopped
Yes.
something from Amazon. Now they are sending you a mail, right? Thank you for shopping from Amazon. Please revisit and all type of messages. Okay. So what that one application from AWS is sending a message to you, say Gmail, Hotmail, any of the mail, and this message is received by a person, right?
Okay.
So what? See, there's an ATM machine. Okay, there's an ATM machine which where you will go and use your card, credit card, debit card, and you want money from it. Okay, so there is a person here who is operating this machine. So the communication is between a machine and a person, an application and a person. This type of messaging is known as application to person messaging. Earlier, what we were doing, earlier we have followed application to application. Like this one server is there, it is contact.
Mm-hmm. Yes.
This is the
Mm-hmm.
first server which is contacting to. Just let me just make it very much clear to you. So this was server one, which is contacting to S3 bucket, which is again a service. So this application is contacting to this application. Then this application is contacting to server 2. Then this is connecting to another application, that is server S3 bucket, another S3 bucket. So what type of messaging it is? It is
Application to application.
application to application. But when an application, say any of the machine, you can say an ATM machine, you can handle any grinders you have in your home. Okay, any type of machine you can use which is sending message to a person, right? It is known as application
Application to person.
to person messaging. Okay, now let me give you a real-time example of SQS, then we can summarize SQS, okay, with the theoretical points. So see, whenever you go to a restaurant, okay, so there's a restaurant, okay, you want to, your end goal is to, see, first you go into the restaurant, book a table, right? This is the first step you are doing, right? Okay.
Mm-hmm.
Another next thing what you will do after booking the table, you have to order your meal, right? This is the second step. After that, ordering the meal, you have to pay the bill. 3-step process, right? And after paying the bill, what next step you can do? You can just provide the feedback to the restaurant, right?
Mm.
4-step process, right? So first of all, what you have to do? You have to book a table. So there is a special counter for that. You will go to that counter and say that I am willing to book a table. So you can say this is a booking counter. This counter will contact to their waiters or managing department so that they can assign you a table. So this is the first message which is they are sending to their managing department, and they will provide you with a table. Okay, now you have a table with you. So your first task is complete. How it is complete? Because from the counter of booking, they have contacting their managing department and they have assigned you a table. So first message is being sent for the table. Now how they will know that at this table a person is sitting? So what this managing department will do? They will contact to the waiter and say go and take the order for the meal. So this is the message too, right?
Mm-hmm.
And they will come for your order, right? Another step, once you have done your meal, this waiter, similar waiter will ask for the, you will ask for the bill, right? So another message is being sent to the billing counter, right? After you have paid the bill, they will ask, say like fill a feedback form. So they say there is a feedback form counter also where you have to go and fill a feedback, right? So this is the fourth message. Now, how these people are arranging all these messages, that first message 1 will be taken, then message 2 will be taken, then message 3 will be taken, message 4 will be taken, right? How they do know, how they will know that a person is sitting on the table, a waiter has to be sent to take an order. Once the order is complete, they have to take a bill. Once the bill is done, they have to ask you for the feedback. How they will know? Because they have created a queue format.
Mm-hmm.
Okay, like first message, second message, third message, fourth message, right? So the processing department knows that they will say for booking the table, there is, you can say server 1, server 2, server 3, and server 4. So how they will get to know the task is complete? So in the server 1, they will know that I have completed this message. So first task is complete by the server 1. Booking of table is complete. Now this server 1 will send the similar message to server 2 that my task is complete. Now it's your turn. So what this server 2 will be do? It will send another message for ordering your meal. Once the task of server 2 is done, it will send a message to server 3 and then server 4. In this way, a proper messaging can be done using queue. So this is all about SQS. Getting it?
Yeah, very clear. I got it. I like the sample.
Okay.
Just in. Mm-hmm.
Now what we can do, because it is like your theoretical subject, I have this, see, this is the examples I have told you. Now you are very much clear with the examples, so we can just move with the theoretical part also. So we can start with this like this. Okay. So I'm just writing the points here only. You will have a recorded video, so you can just go with the video also. So first of all, we are talking about AWS SQS service, right? So what is the full form? It is simple queue service, right? This is the full form. Simple means it is easy to understand and easy to implement. Queue means we have to build a queue, and it is a AWS service, right? Now see, first thing about SQS, you can understand it is fast. These are the key points I'm giving you. Okay, the parts I've explained you using examples will be included in this, but it will be in a complete theoretical format. Everything will be same. The concept is same. Okay, so it is, first of all, it is fast. Second, you can say it is reliable. You can rely on the messages, that messages is going to be correct because we are using queues. Third, you can say it is fully managed. Management is very much good because it is done in the form of queue. These points are clear?
Yes.
Now see, what is SQS? Okay, so it is a web server. An application that is running on internet is known as web server.
Mm-hmm.
So what this is providing us, it is providing us access to messaging. Using this service, we can send messages, right? So what is the role of SQS service? It is allowing us to send the messages in the form of queue. Right? This is very much clear to you now.
Yes.
And in this queue, there is an option that multiple messages can wait. Right? I have told you this is the message one. First, it will this will complete. Then second message will complete. So till first message is not complete, this second message can wait in the queue. So you can say it is a web service that gives you access to manage queues. Okay? Messages when waiting condition is applied. Right? This point is clear?
Mm-hmm.
Okay. This point that it is very much reliable, right? And you can scale it according to you, right? So it is scalable process. Scalable means according to you, you can increase the number of messages in a single queue. That is meant by scalable. Okay, it's according to you how you want to manage your messages. And see, this is server 1. This is server 2. This is server 3 servers I'm talking about. Now, every server has its own queue, right? So we have to manage all the servers and the communication between them, how they're communicating with them. So this can easily be done using one service that is known as SQS service. So management of messages according to the servers, according to your preference, like if you directly want to contact server 1 with server 3, you can manage that using SQS. Another thing, decoupling.
Decoupling. What does that mean? Coupling.
See, what decoupling means, that two processes are not coupled. They are independent of each other. Like this is independent, this is independent. So decoupling means there are two individual processes, right? This is server 1, this is server 2. If server 1 fails in any of the cases, okay, there will be no impact on server 2.
Okay.
In coupling, what happens? If server 1 fails, then server 2 will automatically fail. But in SQS, it follow decoupling. Means if one server fails, it will not cause problem to the functionality of server 2. Getting it?
Okay.
Okay. Now see, because there will be thousands of messages, right? In a queue, there can be thousands, or you can say multiple messages. You can, according to the user or according to the people who are hitting the website, right? There can be multiple messages. So using SQS, you can easily arrange these messages because it is not following any decoupling, that if one server fails, the messages of this server can easily be transferred to this server. Getting it? So no process, if this server fails in SQS, what will happen? The messages, the queue, you can easily shift to S2S server. So all the messages that are received by server 1 now can be implemented by server 2. This is the most biggest advantage you can say of SQ when we use SQS service, because it is offering decoupling. Getting it? Clear?
Okay, clear. Like it.
Another thing you can understand, that this is SQS queue. It has M1, M2, M3, M4, multiple messages given for this server. Okay, this is the server 1 and this is the SQS queue for this server. Now, if you want to delete all the messages inside this server, SQS queue, you can do it without deleting the SQS queue itself. You can delete all the messages and you will get an empty new SQS queue for the same server. So this is possible in SQS. Getting it?
Okay.
Another thing is that, third thing, EC2 instance. Now try to understand the link between EC2 instance and SQS, how they are connected. So see, you have to, if you want to use any application in AWS, okay, you have to create a EC2 instance. That is clear? You're very much familiar with EC2 instance now?
Yes.
So first step is to launch the EC2 instance. Then what will happen? To read all the messages that is inside the SQS queue. So how it works? See, if you want to work with SQS and handle the messages and in the form of queue, first of all, you have to run an EC2 instance. Inside that, you can add this service called SQS. Directly without using EC2 instance, you can't use SQS service because there is a rule in AWS that first you have to build an infrastructure. Okay, you have to build an infrastructure, then only you can buy rooms inside this building. This infrastructure is like a building, right? That is that AWS cloud is providing to us, right? And these blocks are the AWS services which we can use when the infrastructure is ready. So this infrastructure is given by EC2 service, and now inside that you can use multiple things like S3 bucket, SQS, SNS. Okay, so first thing is you have to create your EC2 instance. Getting it? You're able to understand?
Can you provide me another example?
Sorry?
Can you provide me another example?
Okay.
Um,
See, this is the EC2 instance. What EC2 does? In AWS, EC2 is like a build, like, let me explain it to from very much basics. See, I am considering you are not very much new to EC2 also, okay? So, whenever we use any cloud service, like AWS we are using, why do we use this AWS service, AWS cloud? Because in our local system, we don't have either, we don't have space, or we don't want to buy any hard disk, any processor, RAM is low. These are the main conditions why we switched from local system to cloud, right? Like our operating system cost, license operating system cost high. These are the main reasons why we shift from a local system to cloud, right? So in AWS, what they are doing, that they are providing an infrastructure to us, which is known as EC2. Under the EC2 service, they are providing us the infrastructure in which they will provide us the operating system, required hard disk. For space, they have a service called S3 bucket service, and many more services they are providing. So this EC2 instance is like your own local computer on the cloud, right? Now inside this cloud, your own personal computer on cloud, you want to design a system which can send messages from one application to another, right? That's why you are using a SQS service. So if you want to deal with SQS service, you should have a EC2 instance running on your AWS cloud. Otherwise, not be able to access the SQS. Getting it?
Okay, got it. How I have a question. How old is the cloud? Because I heard about the cloud computing like 10 years ago, but I don't know if it is older than that.
I'm also not very much clear about the history of cloud.
Mhm.
So I'm not from cloud background. I'm
Okay.
a scientist.
A
So
scientist?
yeah, I'm a data scientist.
Oh, okay, okay, cool.
Okay. So I work with machine learning, data science, artificial intelligence. So AWS Cloud we use usually for deploying our machine learning models. Okay.
Oh,
So I'm very much familiar with all the services, how to use it, what they required, and why they are used. But I'm very much new. If you will ask me like in which year they have implemented, I don't know actually. So you have to just go and search on Google,
on
Wikipedia.
Google. Got
Yeah,
it.
this is not a part of my study material, you can say. I'm
But
very,
you explain it very good because I'm getting it.
you're getting it? That's nice.
Yeah.
Okay. So let's talk about billing also. Like if you will use EC2 services, okay, there will be billing charges charged by you by Amazon Web Services. Okay. So as you increase the number of messages, okay, as you going to increase the number of messages in the queue, the billing of EC2 will also increase. Getting it? Means the
Hmm.
if you are taking a queue of size 2, inside this queue only 2 messages can reside, then the billing will be less. But if you will design a queue with 20 messages, billing of EC2 will rise. Getting it?
Hmm.
See, now one thing, once, see, this is EC2 service. Okay, first EC2 service, or you can say first ECT instance. Then this is another EC2 instance. So you have created a like SQS queue here, and here you have another created SQS queue in the another instance. This is Q1, this is Q2. Now, what you can say AWS service provide, this EC2 instance service can easily communicate with this SQS queue for the messages, and this EC2 instance can easily contact with this SQS queues. So in any case, this fails. Okay. So what advantage we have? The advantage we have that this EC2 service is able to access this queue. So all the messages are now being transferred to this EC2 service and they can easily implement it. So there will be no message that will be left unimplemented. Getting it? That is
Hmm.
the advantage I told you about decoupling.
Decoupling.
Getting it?
Got it.
Now, there are two types of queues. See, till here, what we have done. See, I'll explain in your brief, give you a brief. First thing, we understand all the cases SQS uses, how SQS works behind the AWS services. Second, what are the important key points that you need to understand about SQS. Now, the third thing we are doing, types of queues. How many types of queues you can make in SQS. Getting it?
Hmm.
Till here, any issue you have? Any-
And and that's it. I mean, I got it.
Yeah.
I
Okay.
know they have like FIFO and a um standard SQS, FIFO SQS. This is the types of. Okay.
See, one is standard queue and another is FIFO. FIFO means First in,
first out,
first
right?
out. Yeah.
Okay.
These are the two types. Any another type you know?
And no, that's it. Those two.
Yeah, there are only two types of queues you can use,
Oh.
okay, when you are dealing with SQS service. Okay, now starting with the SQS, then he will deal with FIFO also. So it is first point you can understand about this. It is highly, it gives us high through output, means unlimited. This means that whenever you use, see, when you go on SQS platform, right? Whenever you go on SQS platform, they will ask you which type of queue you want to build. So if you will select this standard queue, they will implement on the basis of that. And if you will select FIFO, the functioning of SQS will be based on FIFO. So it depends, completely depends on you, like how and what type of queue you want to build. Okay. So it is giving us, it is giving you the first point about standard queue. It is gives us high throughput, means unlimited. See, there is multiple messages here. So you can, no, it's not fixed that which message you want to, you can say implement. Okay. They can, for what this server will do, this is a server one, this is the S3 bucket. This server one has the messages like M1, M2, M3 messages. So if server 3 means SR S3 bucket will detect message 3 first, so it will take it inside the storage and will start the processing on it. Okay, and it's not like that. If the processing of M3 will not finish, M2 will not work. It will continuously start taking multiple messages inside a single S3 bucket, and it will arrange it like this. At one time, multiple processes can be done on single messages. Let me explain it to you with an example. See, when we talk about standard queue, okay, it gives us high throughput. Means you can access unlimited number of messages at a particular single instance of time. So there are message 1, message 2, message 3, message 4 and message 5. Okay. And this is the server. So you can send all the messages to the S3 bucket. There is no limit. Okay. As soon as the S3 bucket detects any of the message that is available, they will directly send to the S3 bucket, and S3 bucket also start processing multiple messages or multiple requests at a single time. So there is no limit when we deal about standard queue. Getting it? Now in the opposite of this, we have FIFO. What FIFO gives us? FIFO specifies 300 requests at a time. I will only consider 300 requests at a time. And it follows first in, first out method. So first message will go. Second message will go in the second turn. Third message will go in the third turn. And fourth message will go on fourth. So it will entertain only 300 requests. Whereas when we talk about standard queue, it is unlimited. You can send unlimited message to S3 bucket and S3 bucket can process according to it. Getting it? First point is clear?
So a standard is unlimited.
Yeah, it is unlimited. Unlimited requests can be send from the queue.
Where FIFO is only 300
300
requests.
requests. You can say TPS
Mm-hmm.
is a term used for request. Means 300 TPS. It is a unit which we use for request. Okay.
Okay.
If you try to understand another point, the second point, that when we talk about standard queue, at least one delivery. What standard queue says, when I am delivering any of the message from the queue, at least one message should be successfully sent. Right? At least one message should be there which is successfully delivered. Either you process it 100 times or 1,000 times, but whenever a message comes in queue, at least one message, either message 1, message 2, or message 3, any one of them should be, at least one of them should be implemented correctly. But when we talk about FIFO, what it states? FIFO states only exactly one. Exactly one. Means this is a message. So exactly one, only at a time, only one message will go from the queue for the implementation part. And from here, multiple messages can go for the processing, but the minimum requirement of the messages, at least one, means not less than one, but more than one can go. Okay, more than one can go. Here,
At the same time.
one message will go.
Okay.
So, getting it?
Yeah. So for a standard queue, like more than one messages at the same time can go. And for the FIFO, it has to be one at a time.
Exactly one, because it is following the concept of first in, means the message that is first in will go first. So means first means only one. Exactly one message.
Can you provide me a real live example of when to use FIFO, when to use standard?
Yeah, just a minute. So see, if we talk about these are the two. Okay, so you can say apply it for an ATM machine. Okay, this is an ATM machine, right? There is a queue outside the ATM machine. There are multiple people standing, right? But at a time, only one can access this ATM machine. No two people can go together and access the ATM machine. So it's a FIFO. So the person who is standing at the first position will go and can access the ATM machine. Similarly, it comes with the, like you can say, if you have taken an online course, okay, and you have paid a payment for it, okay, and you have given a specific ID to, they have given you a specific ID. And this ID can work only for one system. There are usually very much high paid courses that if one ID is working on one system, you cannot access the same ID on the another system. Like you are using it in your laptop. If I will use the similar ID in my laptop also, this session will be logged out. And it will start running on my laptop too. So they follow a FIFO concept to design such a online class platform. Is it clear now?
Okay.
Like the recent example I can give you, the GRE platform. You have heard about GRE? There's an exam.
Oh, GRE.
Yeah,
Yes.
this is an exam, okay? For this exam preparation, multiple platforms have been created, educational platforms. So one is, I think so, Zambori. In India, it is there, okay? So there's a platform, Zambori. They provide you a particular ID, okay? Or you can say a link. And if this link is running on laptop 1 and someone try to access this link from laptop 2, the session will expire from laptop 1 and they will show you logged out and it will start running on laptop 2. So what is happening? You can't access the same link on two systems at a time. So to design such a complex system so that it can easily detect, we will use FIFO concept, FIFO queues. Getting it?
Okay.
And another example for standard queue. See, this is the Amazon platform, Amazon shopping, right? There's a product like chips packet. Okay. Now, what happens? You can go to the Amazon website. You are user 1, right? And you can just go and watch this chips packet is available. So at similar time, another user can go and check this chips packet is available. So multiple users, like multiple messages can be sent to the server that these people are interested in this chips packet. Okay, these many users are interested in this chips packet. So you can say multiple users are interested. Okay, so multiple users can easily access this page of the chips, but either one or more than one can buy it.
At the same time. Okay.
More than one can buy it. Okay, depending on the quantity available. Say here only 4 packets are available. So the people, depending on the message, say user 3, user 4, user 5 and user 1 have already done add to cart. Right? Add to cart and they have started the bill payment. So this chips packet will not be available to the second one. Getting it? Because
Okay.
4 packets are available. They will show unavailability here. So at least one user is involved for buying the chips packet and more than one users can apply for the packet in this condition. So you can arrange a queue that message 1, message 2, message 3 and message 4. So message 1 can be implemented, message 2 can be implemented, message 3 can be implemented, message 4 can be implemented. But if no one is viewing this chips packet, then this chips packet server will be not started. This server will not start because no request has been sent. So to start this server, this page of chips, at least one request should be there. But if there are multiple requests also, we don't have any issue in the case of standard queue. See, this is a server. Okay. This server will show this page of chips if person wants to buy. But when you will able to see this page, when at least one user is there who is trying to access this page, at least one user should be there. If there is no user, we will never be able to start this server. No request will be sent. But if multiple users are trying on the same page, then the availability is there that you can access more than one. That's why standard queue says at least one request should be there. But if you are applying for more than one, then I'm okay. But in FIFO, exactly one. Only one request can be made. Now you're clear?
Yeah.
Please say yes or no when you are able to understand or not able to understand. Be interactive, okay?
Yes.
I will not be able to judge that I need to go further or you are able to easily understand with one example. Okay?
Okay. Yes.
So another thing is about standard. And FIFO. It is best for ordering. All the, if you want to design an application which where ordering is required, ordering of any product, ordering of any, so if you want to build an application which requires ordering concept, so you can go with standard queue. But if you want a queue that is working with the, say you can say, see, ordering can be done unlimited. Unlimited
Unlimited. Yeah. Unlimited
unlimited
message.
orders can be made. That's why we are going with standard queue, right? But if you want to, if where you want to use this FIFO, it depends on, see, the 300 transaction request. Like, I'll give you an example. There is a bank account you have. So in a day, you can only execute 10 transactions in a day.
Mm.
So in this such types of services, you can apply FIFO.
Mm-hmm. Because it's limited.
Yeah, it's limited
message.
to 300 transactions. So you use FIFO where you have to just exactly know how much transactions you need to done. Clear?
Okay. Yeah, clear. I got it.
See, another point. This is the last thing you can easily understand now, that in standard queue, when we talk about duplicacy is possible, because at a single time, multiple messages are going and we don't know in which order it is going. So say if message 1, message 2, message 3 and message 4 are given to S3 bucket. So it can happen that successfully message 3 has been stored in the bucket and message 4 has failed, right? So they are not
Mm-hmm.
able to detect easily that is there any message like named 4 as M4 inside it. So what it can do, it will say I have 4 message requests. Okay, message requests are M1, M2, M3 and M4. I have processed M4 and M3 already, right? But you will not find this M4 request in the S3, so you can easily ask for M3 to get into the S3 bucket. So there will be 2 M3 in the chances of failure. So this can create duplicacy when we talk about standard queue. Okay, so when we are not sure which message is already being implemented and sent in the S3 bucket, we can, because we are randomly and unlimited message can be sent. So we are not sure that which is successful, which is not successful. Say S3 is not able to successfully take M3 message. But in some condition, it happens that M3 message is already stored. So, but S3 bucket will again go to this M3 message and ask it to get inside the S3 bucket for storage. So there can be two M3 messages in a S3 bucket. So there is a chance of duplicacy because no order is followed.
Yeah.
But in case of FIFO, what's happening? Say this is message 1, message 2, message 3, right? So if we are storing this message 1, because it is using FIFO, first in, first out, so we know that in S3, first message has been detected. Now S3 will go and send for message 2. Then message 2 will be inside the S3 bucket. Then it will go and search for message 3. Then it will be inside the S3 bucket. So no chance of duplicacy here. Getting it?
Was what is the disadvantage of having duplicacy?
Because see, this is a server. Okay. Usually on the server, 500 valid requests. Valid means individual request has been made. Okay. And the capacity of a server to deal with the request is say at least 700. So you can
Okay.
500 requests. But if duplicacy will occur, these 500 valid requests can turn to 1000 valid requests.
Wow.
Right? 500 will be valid and 500 will be duplicate. So there will be a load on the server and a single task will be implemented again and again. So when we talk about ordering purpose, if you are going to order for a table, like I want a table for 4, right? If this is the first request has been already made, but again to the table booking counter, same person is going, I want a table for 4, I want a table for 4, I want a table for 4. But originally
Yes.
what happened? They already have been assigned a table. So there will be a mismanagement. So first, time consuming, right? Because much time will be consumed in processing the duplicate resources. And another thing, what can happen? Misuse of resources.
Because of the machine can shut down.
Yeah, your machine will get memory issues. You can have memory issues, processing issues. Sometimes the complete system can crash.
Oh my God.
Have you heard about maybe infinite loops? In infinite loops, this is a part of programming. There, if you say, I want to print, say hi, hello to a single person. Okay. And you have created a messaging, like WhatsApp messaging you have created. And you have set a request like at 8 a.m. daily, you have to send a person a message of hello according to the chatbot. But if this falls into the infinite loop, okay, if this falls into the infinite loop, it will, instead of printing a single hello, it will print infinite hellos, right? So what is happening? The resource used in printing single hello was say 1 byte, and the process of printing infinite hellos means infinite bytes, means memory, or you can say resource wastage. This is known as resource wastage. Resource is getting wasted. Time is being consumed. See, nowadays, because we are in developing stage of technology, time is much more important than space, because space we have a lot now. When we regard to cloud, you can buy the space of terabytes, okay? But time consume, if a resource, if a program, if an application is consuming your time, it is not worth it. Get
Mm.
it?
Got it. Wow, thank you.
Yeah.
Understand.
So let's move to the next concept.
Mm.
So now the complete, whenever you deal with any service of AWS, right? Whenever you deal with the service of AWS, you should understand the billing system, how billing is made. Because sometimes it happens that if you have logged into this EC2 instance and using some services that are provided by EC2 instance, okay, and you have not stop the EC2 instance, the bill will start rising, and you have to charge like a huge amount of money if you have not. See, either you are using these services or not using the services, but your EC2 instance is running. So depending on the 1 hour, they charge X money. Okay, so depend as the hours rises, the money will rise accordingly. So it is very important to understand the billing concept when you are using the services which are paid. Okay, getting it?
Uh-huh.
So we will start with the billing concept for SQS. Like how much billing you can, if you are using this service, how much you have to pay to Amazon. See, when you deal with this SQS service, one thing is clear. Like for first 1 million monthly request, it is free. So in SQS means if you are making 1 million monthly request, okay, you are sending 1 million messages, they will not charge anything from you. Getting it?
Okay.
Once you have crossed 1 million request, then
Yes.
depending on the region you are in, the data center you are using. See, Amazon has multiple data centers. I think so in India, there are 4 data centers for them. From which country you are?
Um, Maybe they have like 6. I know they have a lot.
So see, in your country, there are 6 data centers. Okay. So depending on the data centers, they charge depending on the region. Say I am from India and we use Mumbai data center. This is according to my region I'm talking about. So
Mhm.
standard queue. Okay. For standard queue, they charge $0.40 for next million request. So,
Okay. That's
for first 1 million requests are free to you, right? First million requests are free. Now you want next 1 million request. Okay, so you have to pay to the Amazon for specifically if you are taking standard queue. You have to provide $0.40 in Mumbai region. Okay, and
mhm.
you're dealing with FIFO, right? then you have to go with $50, $50 for
Okay.
million request. This is according to my region, right?
Mm-hmm.
And it is different in your region. So if you will tell me the region, I will just tell you right now only. Region you will use.
Ohio? No, that's not a bit. No, wait. Ohio?
Let me share a screen on Google and let's check for the country what they are providing.
I know they have like Northern Virginia.
Yeah, tell me which country you are in right now.
USA.
USA.
Um, mhm.
Amazon data centers.
Let's see how many regions they have. Yeah, they have US West. The one that, let me see, the one that is closest to me is Ohio. US East. US East 2.
USA East you are in, right?
Yeah. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. Oh, they have 4 regions. Okay.
I think so.
I
These
thought it was more.
regions. US East 1. So US 1 East 1A, B, 1 cause, 1 does, 1 east. These are the requests. So just okay, when we will start the lab practical, okay, like
Mhm.
implementation of these, then we can just see which region you are in and then we can check the billing because you have to keep a strict eye on your billing. Sometimes
Mm.
it takes
Yes, that's
$100
correct.
also if you are
Mm.
not clear with the concepts of billing. So whenever you are using any of the service, be very much clear how much charge they are taking from you, right? So
Yep.
much is clear that if you will make 1 million requests for SQS, it is free for 1
It's
million
free.
request, and depending on the region, for standard queue they have different, and for FIFO queue they have different, right?
Okay, got it.
Now see concepts about how Amazon charge.
That's important. I want to be charged so much.
Sorry.
I don't want to be charged so much.
Okay, I'm not getting it. What you?
Like I don't want to be charged so much money.
Yeah,
Um,
because see, once it happened with me, like I was very much new with EC2 instance, and I
uh-huh.
forgot to close it, and it was running for 3 days. I got $100.
Wow.
So
And
the
what you were using? Well, you were using SQS, everything like easy to use.
yeah, it
What you?
was not in the starting. I'm telling you when I have started learning EC2
Uh-huh.
and all. So I was not knowing that if we will not close the EC2 instance, it will,
Oh,
and it will be added and added. All the services like I was using load balancers and everything for deployment purpose.
okay.
Charges have gone to like 100 USD dollars.
Wow.
But because I'm from my college was offering all the courses, so I didn't have to pay. But with you, it's not the case. You have to pay
Okay.
for you.
I'm scared that I'm very careful
Yeah.
of, audit like requesting accidentally the Snow mobile service. So I'm very careful not to make that mistake. I don't want to see a truck in front of my house.
And Amazon people are very much strict. They will do case on you if you pay the payment. they will. They are very strict with the norms.
Oof.
So let's start like how Amazon SQL charges. So first is API actions, the applications you are providing. When we talk about API actions, so how many APIs you are adding? APIs are the applications, right? You are very much clear with applications, right? APIs we add when we create a web app or any application, mobile application, we add some APIs. And this API contains some concept that needs to be done. So the concept here is we want to send a message. So if you want to add any API, this will consider as one request. So if you're adding any API, it will count as one request. This is the first thing that Amazon keeps. So another is FIFO request. How FIFO request deals. So never add APIs if you're not in required of it. Okay.
I have a question. Just a quick question. What is API again?
See, API is an application. See, it's a like if you're want to perform any operation. Okay. So there are some files to perform that operation that are stored inside an API. Right? If you want to,
Okay.
if you want to add web page. So all the requirements to create a web page is inside stored in this folder, and this folder is known as API, and you have to connect this API to a website. So if you will add multiple APIs, multiple functions can be implemented. So here API means for our system, we just want to create a message, send a message. So this is a messaging API. Another will be how to create a queue. For creating a queue, there will be an API. So we have to add multiple APIs. So what Amazon says, if you're adding any one of the API, I will consider it as a one request. Getting it?
Mm-hmm.
Now comes with FIFO action. How FIFO performs. How they charge for FIFO request if you make. So in API, there are actions comes in. What are API actions? Okay, like sending is a request, sending, like how to send a message is an API request. Receiving a message,
API options, sending, receiving.
deleting a message, changing visibility of the message. See what API actions we have. Now see, if you want to send a message, okay, it will be considered as one API, means one request. If you want to receive a message, it will be considered as one request. If you want to delete a request, it will delete a message, it will be considered as one request. If you change the visibility of the message, it will be considered as one request. So for sending, receiving, deleting a single message, you have made 4 requests. So it is always preferable to make only those requests that are very much needed for the implementation of your task. Okay, so they charge for 4 requests, right, based on rates given for FIFO.
Got it.
Okay, so for 1 million it is free, and for another million if you want to do, they will charge $0.50.
Yeah, depending on the region.
Depending on the region, right? This is clear about fee.
Yes.
Now, inside the request you are making, right? Either it's sending, receiving, deletion, or visibility. Any of the requests you are making. This contains some content inside it, right? What you want to send, where you want to send, how you want to send. Such content is there inside every request you make. So if you want to send a request, say this is a queue that you want to send, right? From server 1 to server 2, you want to send this complete message. Now, when we talk about one single request, if you try to make, for one single request, you can have 1 to 10 messages inside it, right?
Okay.
And the load it can handle for one request, load it can handle is 256 KB. This is the space that it can handle. So if you want to make a one request, inside one request you can send 1 to 10 messages, and the load it can handle will be 256 KB. Now, what can be the size of payload? How payment is made on the basis of load, right? How much load you are giving, they have specified for that also the ratings. Say for each 64 KB chunk, you can say a collection of multiple requests, it is one request. So if we talk about 256 KB of load we are providing, so it will be 4 requests. So the charges will be based on the 4 requests, and if only 64 KB of load is given for sending the request, it will be considered and charged as one request. So 3 things we have learned in the billing section, that each API is considered as one request, right? And and one request can contain 1 to 10 messages inside it.
Yes.
64 KB of load is considered as one request. Single API, or you can say API, can contain can handle 256 KBs. So it can handle 4 requests at a time. Getting it? Based on these things, the
Yes.
made. This is clear?
Yes. Are we gonna go to the console?
Sorry?
Are we going to go to the AWS Management Console?
Yeah, that will I cover in the lab portion for you. There I will
Okay.
show you how you have to do complete thing, like starting from how you can access SQS. First of all, we will make the EC2 instance, then we will go to SQS, how to use it. Either you want to use this standard queue, or you want to use the FIFO queue, and simultaneously I will show you the billing part also. Everything we will do.
I will also look the API.
Yeah, obviously, because without API, if you will not apply API, then what type of request you are going to make? So we will complete, see, I told you, we will go theoretical also and practical.
Implementation.
In this, all the things I am covering in theoretical part, I'll show you the implementation for the practical also.
Okay, like it.
So let me just continue with the part. See, I just want to give you the brief introduction of everything. So when we will be in the implementation part, you can see implementing there by your own eyes, and you can ask the questions that in the theoretical part we have learned this, so now it is implementing. Because there,
Oh,
the dashboard you will see in AWS, the dashboard is like this. Go click on the service and it will launch for you. But you will never know what is going behind this, how it is processing. But in your exams, they will ask how it is built, why it is built, what process they are following. Okay. So I'm
yeah,
telling you
that's
the
true.
backend part. Then when we are very much familiar with the backend part, we can go with the implementation part.
Okay.
See, now what I have to explain to you was visibility concept. See, this is server 1. This is the queue for the server 1. M1, M2, M3, M4 messages are there. This is the S3 bucket for the storage purpose. This is another server, S2 server, right? Which is accessing the same queue. Okay.
Okay, perfect.
It is managing the same queue. Okay, and it will store in S3. It has own one S3 bucket. So what is happening now? The new case comes in. Say S3 bucket, another S3 bucket. I mean, sorry, S3 server, and this is the S3 bucket we are having. So now what concept it follows? It is following that if the user has sent this message, say M1, okay, to the queue, now we are having message called M1, okay, inside. So how many servers are looking for this M2 message? This S3 bucket is looking, this S3 bucket is looking, and this S3 bucket is looking for this message, right? But
Yes.
which S3 bucket will take this message? So it works on sensing technique. Just give me a minute.
Uh-huh.
Yeah. So we are dealing with
I
us.
don't know what happened.
Just let me make it again for you.
Mhm.
This is a queue. Okay. Having multiple message, and this is the message 1, right? And this is a server. The user.
I'm trying.
Hello.
Yes, I'm trying to, let me see. Okay, yeah, I got it now. I see the screen. Okay.
You're able to see the screen?
Yeah, I can see it.
Yeah. So this is a user. Okay. It is sending the request to the server, and server has stored in the SQ. In the queue, they have stored this M1 message sent by the user. Now, what happens in multiple cases that there are multiple storage devices. S3, S3, S3. And there are multiple next servers behind it. Say server 2, server 3, server 4. Okay. Everyone's next step will depend on this message. See, when we talk about any big firm, okay, they will not have a single server working on the platform, right? If there are like Amazon website you are talking about, if you're talking about Amazon website, there are at a particular single time 1,000 users would like to see this website, Amazon website, right? And you have to satisfy all the users so that they can easily see your website, right?
Yes.
For seeing every website, so that thousands of users can see your Amazon website, they have to make multiple servers. And what they will do, they will send 500 on this server, 500 on this server, and any new customer comes in, let's say next 500 comes in. So they will send the request to these 500 so that everybody can go and see the server. This is the chart they follow. Okay.
Okay.
Every web server, behind any website, okay, they follow this chart that there are 1,000 customers coming to me. Okay, they want to see my website. This is the website I am having. Now, how to allow them? So in between there are multiple servers they allow. So say the capacity of one server is 500, another service is 500, and another service is 500. So from 1,500 customer will go here, 500 will go here, and if new request comes in, they will go here. And now they will be able to see the website by connecting it. So the load of 1,000 customers have been divided on 3 different servers, right? So if any of the server fails, you can easily switch to the next server, right? So in this way, they follow the pattern of multiple servers. So say in our example, what I'm trying to tell you, that this user has made a request and on this servers, they have logged in. And you get a message that a new user has logged in. Now, all the 3 servers are trying to read this message. They are continuously trying to read the queue. I told you before also. I told you that every queue S3 bucket is reading. It will always checking that any message comes in, I will call it back to myself. Okay. So it is detecting that any message comes in. So say it depends on the sensing technique. Who will take the request first? Okay. Say message 1 is detected firstly by the S4 one. So it will directly go on S4. But from here, S3 is also trying to catch it. Server 2 is also trying to catch it, and server 3 is also trying to catch it. But at first, S4 was able to grasp it. Okay. So generally what happens, if we will not hide it once it is given, it will create duplicacy, and then S2 server will also grasp it, and S3 will also grasp it. So to stop this grasping of server 2 and server 3, and only one server will get the request of the message, we decide the visibility time of a message. So what is visibility time? In this, for how long this message will be visible. So if a user has send a message to the server has send it to the queue. Now, if from any of the server, say server 4 was able to detect it and take the request of the message 1. Now, inside this S3 bucket, we have M1, right? So it will be removed from here so that S2 and S3 will not be able to grasp it. Getting it? Is it clear?
Yes.
So visibility time of any message, say message 1, you can set in the window like 30 seconds. So what will happen? Say here message 2 is there. So user is there sending message to the server, and server has stored this message to M2. Now all the 3 servers are trying to see this message. S2 is trying to see the message, S3 is trying to see the message, S4 is trying to see the message. But say S3 has seen the message first before S2 and S3. So what will happen? This message M2 will be sent to this S3 bucket, and in this queue, it will be only visible for next 30 seconds.
Okay, what is, yeah, that's what I'm trying to understand, the 30 seconds.
Okay, for this 30 seconds, they will be in this queue. Then after 30 seconds, this queue will be removed, and S2 and S4 server will never be able to read it again. Okay, this is the importance of visibility time.
Visibility time, okay.
This is the first case. First case we have seen when only first case was this, what is visibility time and why it is required. Another concept we can learn. This was clear.
Yes, yes.
Now
Because one of the three services, okay. So
servers.
let's say S3 see the message first. It has 30 seconds of visibility.
Like I'm telling you in this general term, seeing. Otherwise, it is sensing. Who senses it first?
Who sensing it first?
Sensing word is used. Yeah.
And the one who senses first, it has 30 seconds of visibility.
In the queue, in the S
In
queue.
the queue. Okay.
Once S3 has taken this, okay. Once any of the server out of one server, second server, or third server, anyone has sensed it first and stored it in their S3 bucket. Okay, so we need to make a system so that server 1 and server 3 will not be able to access this message. So it will be like 30 seconds or less than 30 seconds. Visibility time you can set according to you. Then it will be visible in the queue for 30 seconds, then it will be removed. So
Okay.
server 1 and server 2 will never be able to access this message because it is already being accessed by server 2 and it is in process.
Okay, got it. Yeah.
Got it?
Yeah. I know now, I understand the logic of the visibility time. Because imagine if we don't have that visibility time, like 30 seconds. So S2 is, I mean, S3, how do you call it? Like the number one is gonna respond, and number two is gonna respond, and it's gonna send the request and at the same time, and then it's gonna be a chaos.
Yeah, maybe you were doing at first, second, and third. 3 persons
Yeah, and third.
are accessing a single system. So this person is also accessing, this person is also accessing, this person is also accessing. So say this person is able to sense it first. So the request is going to this person. Then this person is also sends it, it is going to this person also, this person also. So all the 3 persons have the same request and they have to process the same speed. So it becomes useless.
Useless.
Because you are asking 3 different persons. Okay, 3 different persons to do a single task. When you know one person can do a task, why you are assigning 2 peoples? Wasted of resource.
Yes.
Getting it?
Got it. Thank you.
Another thing we can take the case.
You don't get a lot of thank yous, right?
No, it's okay. I'm teaching you.
Okay.
It's job to clear your all the doubts. I'll feel happy if you are very much sound with the technology now. So we can go with the case 2. Right? Case 2 part. See what happens. The another case. This is a server. This is the user. This is the queue we are having. This is the server 1, server 2, server 3, and their S3 buckets. Okay, now what happens? Say User has sent a request to server, and server has stored this request in the form of message, say message 1. Now say all the three are trying to access this queue because it is a property of SQS that all the servers will access this queue. Now what happens? Say server 1 has sensed it first and this message has gone through this S1 service. And visibility time you have already set as 30 seconds.
That is,
So this message will be available for 30 seconds only. But sometimes due to system failure or sometimes due to error in the message, due to errors in the what you can say in the system, in the message or the request you are making, what happens? This message M1 will not be able to get stored in S3 bucket. This fails here. But because you have specified visuality concept, so this will also be removed from here. After 30 seconds, it will, because what is our concept? That once a server has sensed a message and taken it into the consideration, we have to apply 30-second rule of visibility and no other server can go and approach to this message. Right? So here we have sent the message to M1 message to server 1, but it was not able to store it due to some technical reasons. Okay. So from the queue, the message M1 was deleted and it is also not stored in the S3 bucket for further processing. So in such cases, what Amazon service do? They create a chart of all the failures. Okay, say message 1 failed. So they will create a chart and apply for the reason why this failure has occurred. And after solving this, they can again try to send it to the server and then they will store in S3 bucket. Getting it?
yes.
So in this way, the second case works of the visible time. Is
We
it?
got it.
Yeah. So if you have any doubt, please let me know. Like in any of the concept, you're not sure.
I heard about message timer and delay queue.
Sorry.
Like the dead letter queue. You heard about it? Like yeah, dead letter queue.
No, I'm not familiar with this queue. I am from my experience, I have already only seen two queues. That is standard queue and the FIFO one. But for you, I will check again if they have added new one.
Yeah, they like the dead letter queue is like the message that it is like postponing the message to certain like many seconds. It's like the letter Q is the message that are going to a place that are not like it's not useful. It's used
Like
like
how it is.
something like that. They mentioned like long pulling.
Yeah, I'm coming to that topic, short pulling and long pulling.
Oh, okay.
Topic is not yet over. I was
Got it.
asking like till now the things we have covered. You have any error or anything?
Oh yeah, I'm pretty clear now. It's clear for me like the difference between the standard queue, the FIFO, the SQS, like everything is clear, a lot of examples, different kind of examples.
Yeah,
So
because 1 minute is left. I'm asking for the like 2 hours are complete. So we need to just wind up here because 1 minute of the meeting is left. So I'll share you this
okay.
share you this file, okay? And share you the drive link. You can just go through it. We go through the video again. And for the session, you can come and ask me the doubts, and then we can continue with the next part.
Okay, perfect.
So see, according to me, 10 classes are the minimum I charge for an advance. If you're sure you want to continue, you can just pay me for the next 10 classes. So I think so it will be 20 hours.
Okay, and those 10 classes is gonna cover like everything I send you, like the topics.
Yeah, it depends on the content of the topic. Like from my side, 10 classes or 10 to 15 classes will be enough. But depending on your questions, you want to implement it more, we can extend it. Okay, it depends on you.
Oh, okay, got it. So how many days in a week we can meet?
Yeah, I am available for all 7 days.
Pretty cool. Okay,
I'm
that's
available
fine.
with all 7 days. So from my side, we can have 2 hour class daily, because if we'll extend from 2 hours to much more hours, then it will be like so many concepts in one day.
Yeah, true. So 2 hours. Let me see, 2 hours in
See, 10
at this
classes,
time.
10 days means in 2 weeks we are able to very much clear with the course.
Okay, pretty. I like that one. Like 2 weeks is what I'm looking for. Let me see my schedule so I can agree right now about the 10 classes for every
Yeah, you
day.
can just text me with your schedule, check it through it, and tell me the classes you want and everything. And I think tomorrow we can have one class. And before that, you just let me tell you the schedule on WhatsApp. Then we can agree on the next class.
Okay, perfect.
Perfect? Then
Perfect.
check
So
your
I have to
schedule.
pay the 10 classes in advance, right?
Yeah, for the next 10 classes, like 20 hours you have to pay.
Okay, got it.
Okay.
Okay, that's fine.
So yeah, let's end the class. If you have any doubt, please let me know in the next class regarding the topic.
Okay, great. Thank you so much.
Yeah.
And yeah, I will let you know like some minutes. Thank you.
Thank you. Good night.
Good night.